This video is going to walk us through activity 2. We're going to be doing a leak test on this, a small leak test on this. You see I've got my voltmeter set out, so we're going to be able to take some measurements and we're going to be looking at the pressure sensor. What it's going to do is it's going to seal off the system, so we're going to close that vent solenoid. Then we're going to increase the pressure inside the fuel tank. Now the way we're going to do that is by heating up the air inside the fuel tank. So a comparable situation would be a hot day, your car sitting out in the parking lot, and the heat causes the pressure to increase inside the fuel tank as the fuel evaporates, builds up the pressure. And we're going to see the difference in the voltage going to the pressure, coming from the pressure sensor. So we're going to set this up. We're going to go through the steps in the worksheet, and it tells us to hook up our test leads to the terminals. So we're going to take our test leads, put the test leads in terminal, and we'll go terminal 1 and 2. 2 is the ground, as I recall, and set our meter up to read voltage. And we can see that we have a voltage reading there of just below 1.5, which would be atmospheric pressure. So I'm going to open up the gas cap just to vent it off to make sure we don't have any pressure built up in that system. And we're stabilized. So just a little bit below 1.5 for our atmospheric pressure. We close that cap, make sure the cap is tight. Okay. Now going through the lab sheet has us to hook up the voltmeter, record the actual condition. Now it's supposed to be around 1.5 volts if we're at atmospheric pressure, and we're there, 1.46 volts. That's close enough to 1.5 volts. So is the voltage normal? Yes. Then it says to move the switch for the vent solenoid to the on position. Now when I do this, it's going to turn that vent solenoid on for us. So it's going to energize it, and it's going to close off that vent going out to the atmosphere. So now this system is going to be sealed. Any pressure that's built up inside the tank, inside the canister, is going to be sealed in the system. The next step says to turn the heater on by moving the control switch to the on position. You see that light comes on. As soon as we turn that light on, we can see what starts happening to our voltage. Our voltage starts to go down. So we'll just let this go through. We'll time it out. So we're about 30 seconds in, and we just fell below 1 volt. And we're roughly a minute in, and we see that we're below 0.5 volt here. So we can see as the temperature is increasing inside that tank, it's increasing the pressure, the voltage is going to go down. So the pressure increases inside the tank, the voltage goes down. Now I'm not going to stand here and take this video for 20 minutes, all right, or 5 minutes, whatever it calls for on the lab sheet. And I'm also certainly not going to make you sit here and watch this for 5 minutes of just the voltmeter changing. So we get the point. As the pressure increases, the voltage from the sensor decreases. The next step on the lab sheet says to turn the heater off. So we're going to flip that switch off. It says to leave that vent solenoid closed, and then watch what happens to the pressure. So we see it's fairly stable right now. We'll just keep an eye on it for a little while and see what happens. All right, so now we start to see that voltage increase. Voltage going higher means our pressure is going lower. We've got that inverse relationship. And it took a couple seconds for it to start to happen, but now it's cooling off pretty consistently. Now inside my garage here, it's probably around 55, 60 degrees. So it's going to cool off rather rapidly. But we can see what's happening as it's cooling off. That pressure is decreasing, so the voltage is increasing. Now the computer is going to be programmed to know that given a certain voltage, that indicates a certain pressure. What those voltage numbers are relating to the pressure, I don't know. I imagine if I researched far enough, I could find it, but it's not significant for what we're looking at right now. What we're looking at is as the pressure decreases, the voltage goes up. We can see that smooth change. All right, the next thing we're going to do is we're going to look at a leak. So everything is sealed off. We're just below 1 volt there. What I'm going to do is I'm going to go to my 20 thousandths leak. So on this side, I'm going to open this up. Now I'm going to wait until we get to just at 1 volt. So it's going to get a little timing here. Now when I open that leak, we can see how much faster the voltage starts to climb. So our pressure is decreasing faster. All right, and we can go through and we can see what's happening.